Hello, everyone. Thank you for tuning in to this episode of the Software Plaza podcast. I'm Twain Taylor, editor at Software Plaza. And if you like what you hear in this conversation, go and check out our website at softwareplaza.com. And you'll find a lot more conversations just like this that we've had over the years. And you'll find informative articles on cloud native, Kubernetes, and you'll find other stuff as well, event coverage, job postings, etc. So go check out all that we're doing there. With that said, I'm excited to talk to Pavlo Baron today, who's from a startup named Platform Engineering Labs. So no mincing words there. They've got what they're all about right in their company name, Platform Engineering. And he's the co-founder and CEO at Platform Engineering Labs. And if you look at our backgrounds, you can tell what's common. We're both into music, we're both into guitars, and interestingly, we're both into bass guitars. So he's a bass guitarist, I'm a bass guitarist. So we really got to connect over that just before this conversation. But he's here today to be talking to us about just what they're working on at Platform Engineering Labs. And that's what we're really excited to hear about. Uh, yeah, so quite excited to welcome Pavlo to today's talk. Pavlo, great to have you here. How you been?
I'm doing all right. Thank you so much. And thanks for having me. Great place to be.
Yeah, awesome. Just enjoyed chatting with you about your guitars and stuff, and just surprised that there's so much in common with our musical journey. Quite a fascinating story you have there about your musical journey.
Likewise, likewise.
So I was wanting to just get to know you a bit as we start our conversation. If you could tell us, your background and just your journey and what got you to uh, found to co-found Platform Engineering Labs, that would be a great starting point for us.
Sure. So I live in not so sunny Munich, Germany. Right now, it's not so sunny. Otherwise, it is. And I'm a veteran. I'm in the industry for 35 years. And I basically did everything imaginable in any kind of IT settings, if you
Yeah,
wish.
it's a long time.
I worked in enterprises. I worked in startups. I co-founded startups. So the most recent achievements are co-founding, being CTO of a startup called Instana.
Oh
That
yeah. Okay.
yeah,
Wow.
we exited 2020 to IBM.
Oh, all right.
And yes, I stayed with IBM for a while until I realized that I want to go back on the startup scene because my job is not done.
Mm,
And my co-founder Zachary, he lives in Traverse City, Michigan, and we actually worked together already at Instana,
mhm,
and went through a lot of pain that we are now aiming to solve
mhm.
together. After we exited, our paths separated, so he would go work with other startups, and then ultimately ended up being one of those people who are running the iCloud at Apple.
Oh,
So,
okay. Wow.
right, and that's yes, if you have an iPhone, he was
Mhm.
one of those who is making it work. And
Wow.
we kept talking all the time about the situation in particularly in the broader ops space. I know the
Mm,
term is not very popular, but it doesn't matter how we want to rename that. We can call it
mm,
ops or DevOps or SRE or platform engineering. There's always aspect of running systems, and you cannot remove that aspect. And this is a specific role, and it simply doesn't matter what name we give them. They can be even called sysadmins. It doesn't matter. The
mm,
problems they all have are always the same and unfortunately not properly addressed for many, many years. So
mm,
we just decided that him and I, we are grown up, we are experienced, we have something to say, we're both hackers, we can deliver, and we just want to make it work. So we want to get people out of the misery we had to go through and which still remains the case.
Wow, interesting. Yeah, quite a background there. Instana, iCloud, fascinating. And interesting that you came back to just your roots of just solving problems as a startup, despite an acquisition that you could have just celebrated and probably retired on, but then you still want to build stuff. That's really cool. Um, so, yeah, so talk to us about platform engineering. You've kind of already given us a start there, about how there are a lot of unsolved issues with ops, SRE.
Right.
Um, you know, there's a lot of teams that probably think that they probably made a start with platform engineering, and they probably do have some sort of platform in place. They probably use Terraform. They do some sort of infrastructure as code. But there's probably more to it. They probably feel like, what we thought when we got into this is quite different from where we are now. It feels like we haven't really, you know, uh, we haven't really gotten really in on the promise of platform engineering. Could you describe for us some of those scenarios that you see out there when you speak to people? What's the reality like for those who've adopted platform engineering but still feel like something's missing?
Absolutely. So first of all, I'm a big fan of the discipline itself. For too many years, we kept dancing around cultures and whatever rituals that would allegedly allow us to bring devs and ops closer together. The problem that is actually pushing back here with this approach is that these are completely different roles. And in order to stay compliant, secure, whatsoever, you always have different people to focus on different things. And fortunately or unfortunately for the classic DevOps, is that these people work in different cycles. They actually have different priorities and they have to solve and approach problems differently. So for the first time with platform engineering, now we have a discipline that actually openly admits or helps us admit that yes, devs and ops are different species and they have to focus on different things in order to make it work. And we finally admit the truth that is in every single company that I ever worked with or for is that there is just a small group of people who know everything and who are great at everything, and they work for the majority of everybody else. This is how a successful IT or software a team or whatever, how they actually can move forward without unnecessary friction. This is how it works. And this is great. So we finally have a discipline that says, yes, this is the case. Now, to your question, why there are challenges when you apply platform engineering. Well, the problem is that historically, everything in the ops space relies on just a few people. Sometimes it's just one guy in the overall team, and there's hundreds of other engineers, but it's this one guy who knows everything. They know the whole stack, they've built half of it and everything else, and they are the human API. Everything comes back to them. So they are basically slowing down everybody because they try to establish processes that only work for themselves and everybody else has to follow, starting with tools whatsoever. I mean, I'm yet to see a developer team who really wants to use a tool like Terraform, for example. It is it is not their tool. On the other side, we have tools like Pulumi. They are targeting developers, but I don't know any ops guys who want to use that because the ops guys don't program, they don't code. It's basically scripting what they need. They're thinking imperatively or even declaratively, and this is enough for them. So there is no software development going on there. There is no experimentation whatsoever. And the real trigger why we started it all is that we see that there's a humongous divide in how developers are being helped with everything out there right now. They get all the shiniest tools, all the abstractions, all the cool stuff, all the AI copilots and whatsoever that perfectly fit their mode of work. But there's nothing that goes on the upside of things to help those. And they are working with tools that are already like 50 years old and never have been built or designed for the case of, platform engineering. They are still
Mm,
all operating in the same way. You are the guy, you are in the middle seat, you're in front of the computer, and you tell this dumb computer what to do, exactly what to do. Come on, it's 2025. We have AI out there. So much stuff is going on. Just pulling over something on top of this kind of tools will not make any sense because it doesn't work. What we need is a radical change in some tooling. And this is why we started it. We want to change a few things.
Wow, that's quite an introductory statement there, where you talk about just so many issues around in the space. Quite fascinating. Yeah, and it seems like from what you're saying, that there's two different planes developers and ops folk work in, and it seems like developers tend to have more innovation happening with the AI tools and all of that. But you're saying ops still uses 50-year-old tools. Quite a statement there. Um, and really interesting that you also pointed out how the solutions that exist today, the popular ones, they solve just for one side of the equation.
Right, right.
So I'm guessing you probably believe that it's possible to solve the equation for both sides, the dev and the ops
It
side.
absolutely is. It definitely is. We just
Okay.
need to innovate in that direction. That is
All right.
important. Yeah.
Wow, really interesting. I'm sure you'll tell us more about how that works, in reality, with just how you built your product. But there's one more idea that I was wanting to dig into, which I came across when researching just what you guys are doing, which is talking about moving from configuration to codification.
Yes.
Uh, so typically, everyone thinks of configuration as like the holy grail of, platform engineering and anything Terraform like infrastructure as code. It's all about config, YAML files. But yeah, I'm interested to know more about the idea of why is there a need to move from configuration to codification? What's the difference, and what does it mean for teams?
Well, um, let me start by saying that the idea of infrastructure as code is genius. And when back then Terraform started, they were on the frontier of everything. And I really appreciate the effort. And unfortunately, the way the tool was designed, it didn't allow for real infrastructure code. And let me
Mhm.
qualify that. And this is one big challenge right now that we're solving. Namely, with a tool like Terraform, you have your code somewhere in a Git repository, and then you reconcile from that code through multiple steps that are, well, due to the fact how the tool is designed. You kind of need a plan, and then you run the plan, etc., etc. Well, at some point you end up having a state file. So the moment you transition from your code into real world with a tool like Terraform, you end up having another source of truth that has nothing to do with your code. It is not being kept up to date with your code that is in Git, and it is only being kept up to date with your reality that is in production, only if you do it, well, almost manually. And this is very unfortunate because this makes it no code, because on one side you are describing or declaring what you want to have in HCL, and then you end up with a state file that is completely decoupled from this. And then you have to maintain this state file. You maintain it basically as a database, if you wish, and it's all on you. You are in the middle of this process. You need to do all these manual dances and all these manual steps. And on the other side, what you mentioned with codification, configuration, this is a different story. I don't know how we ended up considering YAML or JSON human friendly formats. They're not.
Mhm.
It's actually they're built for machines. And well, despite the fact that YAML itself is a very different beast, you cannot really make it schema safe without using 100 other tools. While JSON can be made more schema safe because it comes from a different world. And you end up basically doing all mistakes that are due to formatting or due to the level of detail that you have to provide in there. That is another aspect. You
Mm-hmm.
mentioned configuration. I can tell you that let's go through a simple example. What is the configuration of a database for a developer as compared to the definition of a database from the ops perspective? From the ops perspective, it's really detailed, right? I want to give it storage. I want to say how many gigabytes this thing needs. I want to know how it grows. I want to know all the security aspects, etc., etc. And of course, I want to codify them, right? So at some point, I'm done with that. Developer does not need to know any of that. Even if they want to, I mean, the better developers are curious. Of course, they can, but this is not the job of a broader development team to define in this nifty-gritty, low-level detail how this
Mm-hmm.
database is going to work. That's the job of the platform team. So there's this humongous divide in this configuration too. Not only do you make stupid mistakes because your format is questionable, let's call it like that, but you also are forced to provide detail that you don't even understand sometimes. Like, why would I need to say how many gigabytes my database needs? I don't even know that. I want abstraction. And this is the key word here. If you want to make it work between your platform team and your developer teams, you need to abstract for them the infrastructure in the sense that they work with understandable terms. For example, t-shirt sizes. You just say it's a big database. And what big means for this particular group, platform team totally knows, and they have the budget under control. They have the all the non-functional requirements under control, right? So as you see, it is a very well diverse and complex problem that is due to the fact how tools work. And this is what we're aiming to change, because for most of what I just described, you need one tool, not 100.
Interesting there. One of the things that comes to my mind is how we kind of oscillate between these two sides, where we say on one side, we want to have separation between dev and ops to where, uh, you know, uh, dev takes more ownership of code and building, and ops takes ownership of running and managing in production what's being deployed. And so there's clear ownership that way. But then there was a time when, when DevOps was just starting out as an idea about a decade more or more ago, where we're talking about how have small DevOps teams where, pizza-sized teams that have like dev and ops together, and so dev is aware of what ops is doing. Dev knows a bit of ops, ops knows a bit of dev, and they complement each other. So you kind of break down silos. We are talking about that. I feel like we kind of go between these two extremes, every now and then. And so I was wanting to get your take on this, as you're talking about how, with databases as an example, how ops cares about certain specifications of the database, whereas they don't care about those things. Talk to us about, how that all comes down to, how dev and ops sees each other, how they work together, what they need to know about the other side, and what they do not need to know. What's the right balance? If you could talk to us about that balance.
Right. So I can tell you that I think that in the future, it is absolutely necessary to say that a platform team, I would not go after ops, DevOps, WhatsApp. I mean, I see them inside of this discipline because I think that this is the way to work. I already stated that, right? So
Mm-hmm.
allow me to use that as a reference.
Mm-hmm.
Platform team needs to essentially do two things in order to make this balance work. One thing is they need to own the non-functional requirements, and these are plenty, right? I mean, it can be compliance, it can be reliability, scalability, security, privacy, all these kind of things. And in that they own them, the developer teams are rid of this necessity to really own them too. And this allows them to move really fast. But what the platform needs to make sure is that the developer teams cannot break out of some boundaries. So they set up the boundaries in that they defined services for them that are already building on top of meaningful defaults, all kinds of, details that are not necessarily relevant to a regular application developer. All these
Mm-hmm.
kind of things are completely taken out of the of this kind of cooperation, right, between those two worlds, and they only come up when they need to agree on maybe new things, or when they do a greenfield project. Of course, everybody needs to be involved who has the qualification to do so. But then the ownership for the NFRs goes to the platform team, and their
Mm-hmm.
job is to provide the services that are, you know, satisfying those requirements. And then the developer teams don't need to take care of that, and they're not slowed down because they just request the service on the spot. I need a big database. I need to develop to deploy that application. They shouldn't care if this application ever goes as a container into a pod in the Kubernetes cluster. It's not their job, and we need to be talking about separation of jobs. This is very
Okay.
important. I think if we go down to this level, we can solve a lot of friction and a lot of problems here.
Mm-hmm.
Because a job-oriented or role-oriented thinking allows you to abstract away unnecessary detail and noise. And
Mm-hmm.
this is the foundation for focus, and the foundation that results from that, well, and the result that comes with this focus is speed, right?
Mm-hmm. Mm-hmm. Yeah, yeah. Sure, makes sense. Yeah, so I was wanting to get into just talking about what you've built at Platform Engineering Labs. So the product is called Formae, Formae. Tell us first about even the name of the product itself. It's a unique name. It's not common to hear a name like Formae in the tech space. Tell us about it.
Right. It's unusual, right? Like everything we do is a little bit unusual. So yeah, yeah, we like to be different. So forma is plural of forma, and forma is
Okay.
roughly can be described as outline or a
Okay.
form whatsoever. We truly believe that it is absolutely important to control the granularity of infrastructure changes. That's why we
Mm-hmm.
invented the so-called forma as the means of communicating your desired infrastructure changes from user to our tool. So basically, this is the transport, how you express using code what needs to be achieved.
All right. All right. Cool. Yeah, interesting. So tell us a bit more about Forme's approach, some of the design decisions you had to make at the start when you were just starting to build the product, some of the seed ideas behind it.
Yeah, there's plenty, but the most important, first of all, it's an agent-based system. So yes, it has
Okay.
a backend. I know
Okay.
that when you work with tools like Terraform, if you don't go off the Terraform cloud, you don't necessarily understand why you would need a backend. But there's plenty of ideas that can only be properly implemented using an active backend. And by active backend, I mean something that just sits there without you necessarily having to babysit it, and it does work. That's how I
Mm-hmm.
would describe backend. And
Mm-hmm.
it makes it an agent in that it makes its own decisions whatsoever. We're not talking about AI agents here. That's a completely different story. We're talking about classic agentic systems, like everything that has a name in the broader observability infrastructure, monitoring space. For years, for decades, has been built using agents. And this
Mm-hmm.
is basically you send out these agents into the wild and let them make the job happen, and then transfer the data in any direction. And this is exactly how we do this too. The
Mm-hmm.
change that it brings is obvious, right? You send a asynchronous command into Forme using a Forma file where you provide code. And
Mm-hmm.
from there, our product just takes it over and converges to the result that you declared. You don't need to have that on your machine. You don't need to simulate that like everybody else does with the Jenkins or Argo CD or whatever. You don't need to wrap another workflow engine around it like the other people do. It's already in there. So once you send this command, it will eventually finish. This is what you get within the active backend. The second part that makes it all unique is that I have seen so many organizations that struggled establishing processes that go against the reality. And by this I mean the reality is that you don't want to slow down the overall progress by prescribing rigid processes and tools. You want to let everybody use whatever they want. And
Mm.
unfortunately, in the infrastructure space, the thinking is different. The thinking is like, oh yeah, we need to terraform everything and everybody needs to use it. No, that's not true, especially with the new roles like AI engineers and everybody else who is coming up these days. They have infrastructure changes built in into their own tools. There is something like cloud control that comes from AWS, which is a CRUD for infrastructure resources. The game has completely changed. You don't need all this kind of artificial slowdown anymore prescribing one tool. What you want to do is to let everybody do whatever the heck they want and get yourself in the position of control. That's what you want. So you can make the decisions. Did they do the right thing? Or if they didn't, I need to roll it back, right? You don't want to slow them down. People move fast only when they're allowed to use the tools that fit them well. And this is what we do. We have not only this active backhand or agent. In our case, this agent also does work that you didn't tell it to do, namely, it automatically discovers all the new resources that show up in your accounts, in your AWS account, no matter where they come from. They can have been terraformed or they come from Pulumi because one team is using Pulumi, somebody else uses Crossplane, somebody does ClickOps. I mean, ClickOps, really, it's a completely underestimated tool, but I can tell you, if I wake up at 2 a.m. to fix a single thing and I want to get back to sleep within 10 minutes, I don't I don't want to see anything. I know the exact spot where I need to go and change something. So we really need to accept the fact that tooling in the infrastructure space is diverse. And what is really needed is that you have this state expressed as code and you have it under your fingers, always up to date at any time. And this is what this other role is that our agent does, namely discover resources, synchronize changes on resources that it already knows, and codify everything into a single source of truth that you can use to check out your code, make changes, send them back, or just simply lean back and observe what others do and just, see, oh yeah, I don't like it. Let's revert that.
Uh, I found like the statement that you made quite, quite thought-provoking, which is you mentioned how that we don't need artificial controls, and a lot of these accepted tools and solutions out there, that's what they do. They place artificial controls that slow down people. Quite an insight there. That's really profound. So yeah, so with Formae, I guess you're looking to sort of remove obstacles, get things out of the way, and simplify and just have what is necessary and remove what is unnecessary. And you're probably trying to reinvent the way things are done a decade ago. And you mentioned some of the tools that, Jenkins and Terraform, two of the tools that you mentioned that place artificial controls on how people do work. Uh, yeah, that was quite fascinating. I thought that was really profound. Are there any other similar things that come to your mind, like when you think of like Jenkins, Terraform, and what they do? Any other similar things that you feel really slow people down? Any similar solutions that you feel are accepted but that slow people down? Or these are the primary ones that you really that come top of your mind, and that's the ones you really focused on with Formae.
Okay, you want a real thought-provoking thing, like literally every tool I know in that space is not built for collaboration and it's not built for speed. Most
Okay.
of the tools, like literally most of the tools, except really the newest ones that are coming up, including ourselves, are built for one guy sitting in a room without windows, listening to the reels, zooming and everything, and being the person who drives it all. I know
Mm,
there's enough of people who like this mode of operation, but let me tell you something, that doesn't work when teams are involved. We ended
mm,
up in a situation where there's one guy knowing everything and nobody else is empowered. Nobody else is
mm,
enabled. We have
mm.
armies of engineers who don't know how to actually break out of it unless they really get the permission to break out, and then they start doing whatever you want. So you have a paper process, right? I mean, I can tell you, people should be honest with themselves. Look inside and see how many paper processes you have. And
Mm,
these are the slowdowns. And I mean, this is not bad. These tools had their time. They were actually, at the time they were invented, they perfectly made sense for the mode of operation back
yeah.
then. But it is normal that they are growing old and not really kind of fit the modern way of work. And I can
Mm,
tell you, there's another big challenge. Let's not talk about tools. Let's talk about demographics.
okay.
We have a humongous problem is that people who know how to run the systems, yeah, I mean, we're getting older and older. Young
Mm,
people coming up, seeing TikTok, Instagram, whatever, and how the UX there is. I mean, you show them the Linux shell, mm, I don't know. So
mm,
there is also a movement with kind of rethinking, rebuilding how this user
mm.
interface, being the shell, works, how it talks to you, etc. And
Yeah.
this is the exciting part. The developer experience under the broader discipline of like user experience needs to change. So every single tool, if it wants to survive, it needs to adopt, or it's going to be replaced.
Wow. Amazing. Yeah, that's quite another, I mean, you're dropping a lot of bombshells here. Uh, um, yeah, really fascinating. One of the things you said earlier also, I made a bookmark of it that I wanted to come back to. You said JSON and YAML are not designed for humans, they're
Right.
designed for machines or something on those lines.
Yes.
Tell me a bit more about that. So, what was your solution to that issue? How does Formae approach, what configuration differently from, JSON and YAML?
Yeah. So we decided to make our front end uh, to build it around the language called Pickle, PKL. I'll provide the links afterwards. And
Mm-hmm.
there's a similar language called KCL. It's inside of the CNCF. But we decided to go with Pickle first. And
Mm-hmm.
the deal with this language is that it's you cannot really clearly specify, the shelf it needs to go on because it has all the programmatic aspects that are good enough to move forward real quick. Like it has really native loops and conditionals, something that
Mm-hmm.
HCL actually pulled over later on top of
Mm-hmm.
what it had before. But it's not as complicated as a complicated TypeScript application can be, right? It sits right there in the middle. But its goal, even without Formy, it's basically rendering from sophisticated schema-based and very simple expressive declarative language onto any target format. That's what Pickle originally does, and Pickle comes from Apple. It's open source, but Apple uses it massively. And they solved one problem with that, and everybody
Mm-hmm.
should be solving that problem. It doesn't matter if they use a product or not. Of course, they should, but Raw
Mm-hmm.
Pickle solves one problem for you. You don't make stupid mistakes when you configure stuff. You
Okay.
you you can't have your YAML misformed, which leads to multi-million outages. We've heard
Mm.
all these horror stories. You
Yeah.
don't you don't need to do a lot with this stuff in order to make it work. If the renderer says it's okay, you can be absolutely sure that what you send to the next tool in the
Mm-hmm.
output format is going to be correct. And what we did with Form is we took it on the next level. We said, okay, well, we're not rendering in between. We are executing what you give us as form as a forma written in Pickle. So basically, we eliminate any human error that can be done prematurely before they send it into our tool. The renderer
Mm,
says yes internally. Our tool takes over this forma and it executes exactly what this forma says. So you have a reliable chain of things that happen here without having to debug complex YAMLs that are somehow misformed, whatever you did there. It doesn't matter. It shouldn't happen. So
mm,
we completely eliminate that. But there's also another thing that comes with programming languages, and I mean, if you use Pulumi, if you are really on the left side of things and are sold to that, so that works more for like, I don't know, smaller setups where there's no real ops whatsoever. That's actually a great way to move. When you have a programming language at hand, is abstraction. Again, I mentioned this word already twice. You can
mhm.
abstract. What you also can do with Pickle, what you can do with any YAML whatsoever, you can abstract on multiple levels. Imagine that guy who knows everything, right? This guy
Yeah,
owns the whole detail. They know the exact algorithms for encryption. They know all kind of regional aspects in AWS whatsoever, right? I mean, they know it all. They know all this works, right? And
yeah.
they codify it in Pickle. So they
Okay.
express that in Pickle on the low level detail. Now they have
Mhm,
less sophisticated or experienced engineers or people with different responsibilities in their team that are just focusing on one particular sub area. Like there's a guy who manages databases. So they
mm,
don't have to touch networking, not necessarily, right? They don't need to touch security whatsoever. They focus on the database layer, which is on top of this other layer, and it's abstracted. You don't need to know how this VPC is configured. You just need to know there is one. And that is
mm,
your requirement, right? You say, my database needs a VPC, needs a subnet, needs this, this, and this, right? So
mm,
one level up. So you're already abstracting inside of the platform team and so on and so on. And for operators, for example, this is another thing that is great with our approach is that we not only allow you to think holistically, so holistic thinking is a classic approach how you do infrastructure as code right now. You
mhm.
always make changes on the whole code base and you always roll the whole thing. So basically,
Okay.
everything is just it's always expressed in as a well, you can express it as a diff to your previous code, right? What
Mhm,
we went one step further and said, yeah, actually, the reality is there are so many situations where you just need a patch. A patch is well, imagine you need to change one single property,
yeah,
a single resource. You don't need to
yeah.
touch anything else. And even if you are absolutely experienced, again, this guy waking up at 2 a.m. in the morning doesn't want to know any detail either. He just
Mhm,
wants to set the new value for the JVM memory. This is the only job he has right now. Okay, and this allows this additional abstraction. When it goes to developers, we're very simple there. If you have developers who want to know more about infrastructure, they can also layer their own stuff with Pickle on top of what the platform team prepared. If they don't want to do that, they will simply get prescribed, predefined properties from a forma, and they only set a few values. They don't even touch Pickle. They can put it as a drop down in their own CI/CD tool, and they're done. This is it. It's completely abstracted from them. And imagine what possibilities come then with this approach if you do something more sophisticated and still a little bit new, like infrastructure from code. When you define in your code what you actually want to run on, but not in terms of I want to run on Kubernetes as a pod. No, that's not what you say. You
okay.
define you are stateless or stateful. You define you big, medium, or small. You define are you multi-regional or not because you need to say that, yeah, there's a failover whatsoever. Probably not even that. There's just a few things that you want to define. We provide them as properties where you don't even need to touch the code at all and still work with the infrastructure code.
Mm-hmm, mm-hmm. Wow, interesting. Fascinating. Kind of comes down to kind of these bedrock ideas of infrastructure as code, which is about being declarative, and also about just the idea of immutability when releasing changes and updates.
Amen.
Those are kind of two threads that kind of seem prominent in what you just spoke about. But fascinating and kind of new and interesting approach to just this entire way of doing infrastructure as code and platform engineering. So thanks for really breaking that down. So yeah, at this time I was wanting to play this recorded video that we have of Formae and just explaining what it is and how it works. So we'll do that now.
Formae automatically discovers new resources and turns them into versioned infrastructure code. Let's demonstrate that with a cheap resource. AWS Internet Gateway is a very cheap resource. Let's create one through ClickOps. The moment we clicked all these buttons and links, Formae already sees this resource. Now let's extract this resource from Formae as pickle code. We need to tell Formae that this resource is yet unmanaged, which means that you cannot make any modifications to this resource through code yet, but Formae will automatically track changes on it already. Now we want to put this resource under management, which essentially means to give this resource a stack. The only thing you need to do in Formae to achieve that is to apply a patch using this Forma pickle file. And this is what we're doing here. With a minimal blast radius, we're not touching anything else. And by the way, a resource under management doesn't mean Formae exclusively owns it. You can still use ClickOps or any other IAC tool to manage this resource. Now, after this patch, Formae knows two internet gateways and manages them. Let's extract the managed internet gateways as pickle. Let's look at the code. You see, we have two internet gateways under management.
Okay, I hope you found that informative. Just had a couple of questions more as we wind down. I want to ask about just a specific question about, this specific feature that seems interesting to me, patch-based changes, something that I read up, and how it relates to reducing the blast radius. It seems like an interesting feature related to security. Could you talk a bit about that?
Yeah, there's in our case, there's two types that we also have in our examples, and people can look them up. So blast radius is all over the place. This discussion goes on and on and on. How do we reduce blast radius and blah, blah, blah. The thing with this term is that looking at the current tools, it appears very artificial but urgent. What I'm saying by that is this: if you deal with a tool that works only holistic and does reconcile one way, your blast radius is it's questionable because you always have the whole detail in front of you. It doesn't matter how you cut it in modules. If you want to make it work and want to make sure that this thing is going to execute properly, you will have to look at the whole thing anyway. And it doesn't matter how you structure your code. That's not a code structure problem. So blast radius is a problem of a tool that needs to work in the following way, and this is how Formae works. Somebody who has to change a single thing, a single property on a single resource, does not need to know any detail, does not need to see any detail. They have one job, just to change this thing. So we give them the ability to work with our product using formas in any granularity. You can roll the whole infrastructure, you can roll your whole database, or you set one single value, and this is a change that we apply as a delta to what we already know reliably and version it so everything works like under the hood, like what you know from Git, but it's not Git in the broader sense, so it doesn't come with all that complexity. You don't need to roll that. We just version them forth and forth, right? And the other thing is patches also come from the outer world. It's out of bound changes. Somebody did ClickOps. So we also grab this change, discover it, and put it into the system as a versioned patch. And this way, we allow you to satisfy one thing that blast radius needs, namely to be able to extract that much code and change that much code rather than to have to extract files, work through files, find the spot that you need to change,
Right.
Go through all the cognitive overload that you have to deal with, whatever your situation is, and then apply the change, hoping it's going to go through and you really pick the right spot.
Yeah, yeah. Kind of goes back to what you mentioned about at the start about granularity and just control over changing exact parts of your stack. Quite interesting there. As we wind down, got a last section where it's a rapid fire section where I'll ask you a couple of questions. You just shoot with what comes to your mind first. So here goes. One myth about infrastructure as code you'd like to get rid of.
Explicit state management, of course. That's the
Sorry.
first thing. That's the first thing you can Google out there.
Okay. Explicit state management.
Yeah,
Is it?
you have to deal with the state file whatsoever. I want to get rid of all of that. That's not up to
Right.
date.
All right. All right. Cool. Cool. Okay. Next one. Your biggest aha moment when building Formae.
Um, uh, the biggest aha moment was we had so many ideas that we had to put them on a back burner in order to make it work for the launch. So the aha moment is that we can make it work with a very small team, with the tools that are available right now, with people who are smart and very experienced. We can come up with so much. That was my biggest aha moment. I really love that team.
Interesting. What would you say is the most underrated skill for modern platform engineers?
Oh, this is a hard one.
Hmm.
I think that I'm seeing that the classic understanding of what is the job of the guy who runs systems, the ops guy, I think this one is fading away slowly but steady.
Okay.
I think that we need to make it more prominent. We kept talking this away for many, many years as a community. We need to be clear that this is a special job that requires special skill
Hmm.
and it's a lot of responsibility. So you're biting your fingernails all the time, like all day long. You go on calls, you rescue systems, you rescue lives if you wish, right? Just by unscrewing situations.
Hmm.
And I think this is something that needs to be more and more prominent still. I know this is not popular because everybody wants to engineer things and whatsoever. But this is also kind of an engineering. When you look back at how classic engineering worked, you build it, you run it. And that's what you need to do here too.
Oh, interesting. What's one favorite open source project that you wish more people knew about?
um, it's a whole community, I would say. I'm a big fan of Erlang. And
Okay.
Erlang, I mean, probably don't know it, but this is a ecosystem and also language that was built back in the day to allow you to run massively parallel software system with a whole bunch of tiny components called actors that exchange messages between each other. And I would say this whole idea and ecosystem and something also, Akka, for example, and Scala needs to be a little bit more prominent there. People need to learn that parallel systems or highly distributed systems, whatsoever, are very complex. This is, you can't underestimate that. And there are platforms that actually take away a lot of this complexity. So you don't need to touch it by introducing a few paradigms that you need to follow. So what we did here, of course, Erlang, since this is still a niche, unfortunately, even after so many decades it exists, we basically used a project called Ergo. It's Erlang on Go. So we
Oh, okay.
basically didn't use Erlang as language, but the project is growing, and I think this deserves more attention because it allows you to implement real interesting concurrent and parallel systems on just the Go runtime inside of your program.
All right. So go check that out. I'll go. All right, with that, we come to the end of our conversation. Thanks so much for joining us today, Pablo. It was quite a pleasure chatting with you today. And yeah, I hope you'll come back again if you release something big at Platform Engineering Labs. Come back and tell us about it. We'd love to have you back.
Absolutely. Thank you so much for having me.
All right. Thanks to all of our listeners and viewers as well for tuning in. We hope you enjoyed this conversation. If you'd like to know more about Platform Engineering Labs and the product Formae, go check out their website. Just do a Google search for Platform Engineering Labs, or their website is platform.engineering. That's where you got to go. And check out what they're up to. They sound like they're really pushing the boundaries and really innovating and doing some cutting edge stuff. So you'll definitely want to go and see what they're up to. And with that, we're signing off for now, and we'll see you on the next episode. Bye-bye.